Thank you for reminding me about the recording. So what we're doing now is we are going to write a recursive function that takes in a positive integer and returns a Boolean. And that Boolean is going to indicate whether or not it's even. So even or odd. So now we just want to write the basic framework for this function. So don't worry about any of the logic inside of it. Just give me the kind of outline.
Def is even. Um, and for a parameter, it just takes in num.
Okay. And what does it return?
Uh, Return true.
Yeah, so we could do something like that. So it's going to return some kind of Boolean. We'll just do true for now. Okay, so we have our function signature, right? So we have the function, we know what it takes, and we know what it returns. So a lot of the trouble, I guess, with recursive problems is that you have to think about them in a different way. So if we were doing this normally, so obviously I'm not going to let you use the modulo operator, but uh, so how can we think about this kind of problem? So the first thing you want to do is try to make it like a physical example. So don't think about programming for a second. So we have, you can ignore this for now, but let's just say we have a number. Well, how do we know whether this number is even or odd?
If you divide it by 2 and it doesn't have any remaining number, then it's even.
Yeah, okay. So we could divide it by 2, and if it doesn't have a remainder, so 5 divided by 2 is 2.5, so there's a remainder. So it's not even. If we have 4 and divided by 2 is 2, there's no remainder, so we know that's even. But I'm gonna again put a restriction on this artificial restriction and say we can't use division.
You could keep subtracting by 2 until you get to 1 or 2.
Okay, good. So you've kind of hit on something that you want to do when you're trying to solve a problem recursively, which is what is the simplest possible case you can come up with. So if we're trying to figure out whether or not a number is even or odd, what is the simplest possible value for odd?
1.
Yeah. So if the number is 1, then we know it's odd. And what's the simplest possible case for even?
0.
Yeah. So if if we have a 1, then kind of trivially we know that it's odd, and if we have a 0, then we know trivially that it's true. So that is our base case. So we've just kind of, we have a problem and we try to think of the simplest, basically trivially true example of a solution, and that's going to be your base case. So base cases sometimes can just have one case. Sometimes your base case could have several different sub cases or whatever. So in this case we have 2 options. So if num is 0, then return true, else, or if num is 1, return false. Okay, so we've got the base case, so that's good, but this is not going to be that useful of a function because can't really tell people to just pass in 0 or 1. So we're going to need a recursive case. That's going to be here. So what kind of work do we need to do in our recursive case? Let's not worry about the actual, logic what we're going to do. What kind of thing are we going to need to do at the very least?
Decrement the original number by 2.
Yeah, so let's just say we don't have that solutions. We don't know, we don't know if it's going to be 2 or whatever, but we know that the recursive case, the fundamental job of the recursive case is to reduce this input to one of the base cases. So the job of the recursive part is to break down our input until it matches a base case. So if we start with a number, let's say 5. If we check here, is it 0? No. Is it 1? No. So now we have a 5, and we somehow need to bring this 5 closer to a 0 or a 1. So how do we bring a 5 closer to a 0 or 1? We can subtract. So we know at the very least that we have to subtract. So again, we don't know exactly what we have to subtract, but we know that there's going to be some kind of reduction. So, and I'm again artificially saying you can't use division or anything. So subtraction is basically our only option. So it's going to be x minus, or x minus, or it would be num minus x, something. So we're going to do something along these lines. We don't know what x is yet. So we're going to take a number and we're going to subtract it. And then we're going to pass that in. So if we think about, again, let's step outside of the coding. So I think we already know the answer, but let's try to work out without using code a possible case. So let's start with 5. So how do we get a 5 to a 0? Or in this case, we know 5 is odd. So let's try, and how can we get 5 to 1?
I mean, we subtract 5 minus 1.
Okay. So
Like,
yeah, so let's go through that process. So 1 is a possible option. So we take 5 and then oops, I don't want to do that.
like 5 minus 1.
This is not wanting. There we go. So let's do the -1 algorithm. So 5 to 4. Okay, is 4 0 1? No. I'll just do it this way. So let's subtract 1 again. 3 is 3 0 1? No. -1, we get 2. Is 2 0 or 1? No. And then we get 1. So is 1 odd? Yes. So that looks like it works. Now let's do the same thing with 4. So we have a candidate solution, right? We subtract 1 every time. We have a test input, and then we get a successful result. So that's a positive hit. But we should also test this other case. So 4. So 4 minus 1 is 3, 2, and then 1. And this is one of our base cases, right? So 4 is not odd. We know that. So there's something wrong with our algorithm here. So before we go any further here, what I'm going to do is I'm going to write some tests. Because I know, let's just say you're not always necessarily going to know exactly what the answer is to the problem, but in this case we do. So I'm going to write some assert statements. is even. We'll start with some trivial cases. So 0 is true. So I'm using very simple, this is a very simple test. You can obviously and probably should use something more robust, but for this example, it's fine. So 1 is going to be false. And let's do 3 is going to be false. And 4 is going to be true. And then maybe we'll do some bigger numbers. So 100 is going to be true. 101 is going to be false. And that's fine for me. I think this is probably fine. So again, we're not concerned about validating input. We're assuming we're getting a positive integer and so on. So you could write more test cases, but I think it's probably good for now. All right. So going back to our problem, thinking about the solution. So what's one reason why we might want to write a bunch of tests in advance, let's say?
I guess if we're like familiar with the data from the problem we're trying to solve, and we know that there are possible inputs that our function could receive.
Yeah, exactly. So this will work better. You know, the more you kind of know about what you should expect, the easier it is to write tests like this. Sometimes that's not always the case. Sometimes there's also something called property-based testing, which I might talk about a little later, but it's basically a way of saying, you know, there's certain kinds of inputs that I want with certain kinds of outputs. So you don't have to individually write each single test case. You can kind of use a auto-generated library. We'll just give you an integer and then and so on. But anyway, yeah. So the benefit of writing tests in advance is that you know that it works. So whatever I'm doing here, this is scaffolding for me. So I'm not just kind of testing one thing at a time, and then maybe it works with, for example, 4. So if we're doing let's do num -1. So we haven't finished this, but let's just say we're using -1. So it works for well, I guess it wouldn't work for these two, but let's just say I'm testing it with 5 or whatever. It works, right? It works if it's an odd number above 1, I believe. So there's certain inputs that it works for. So if I start writing my function and I just test it, you know, with that one input, oh, it works. And then maybe later on you try with something else and it's like, oh no. So I implemented a solution and didn't realize there was a bug in it until later. So if you do this, you provide yourself some scaffolding, so you know that when you come up with a solution, that it's probably going to be a good one. And the better the tests you have, the more certain you could be. Okay, so let's go back here. And someone already said it, but so 1 isn't going to work. Let's try 2. So if I take 5 and I subtract 2, I get a 3. That doesn't hit our base case. We subtract 2, and we get a 1. That does hit our base case. So that works for odd numbers. Let's test even numbers. So if I start with 4, I subtract 2, I get a 2. And if I subtract 2 again, I get a 0, which does hit our base case. So we just did some very cursory test, and we figured out a solution to this problem without actually writing any code, right? We're just trying to figure out what the problem is. So let's say we figured out that we can determine if we subtract 2 that we can figure this out. So it's something like this. So what's the rest of this else statement?
You have to return a function call.
Yeah, so we have to do some kind of recursion.
Return is even -2.
Yeah, so return is even. Do I have to return it?
I think it would work without the return. That's it, because it would still call on every case, I think.
Any thoughts?
I think you need to
I think
return
it
it
was better.
because you have to return the returned answer.
Yeah, so I'll print this out. So we thought that we had a solution, right? But I'm getting some kind of error. Is 3 false? So it's not like totally failing. I mean, it's failing on this third test case. So it seems like this kind of works, right?
If you don't return it, is it not updating like Noel said?
It could be, but let's try and think about why. So we're pretty sure that this solution works, right? We're pretty sure that we know how to solve the problem. We need to decrement by 2, and we know that we need to use recursion, so we're doing that. And we write some test cases to kind of provide us some scaffolding. But why do these first 2 work and this third one doesn't?
Oh
You can go
no.
wrong, it would fail on all of them, right?
Because the base cases are 1 and 0, right? So that's why.
Yeah, so 0, so let's just walk through the example. So if I start with 0 here, if num equals 0, return true. And I returned true. That's what I'm testing, right? So what is the return value of is even equal to 0? It's true. And that is. So let's try 1. So put 1 up here. No. I return false. So the return value of this is false. What is the return value of is even? So let's walk through this. So 3, no, these 2 cases don't hit. This case does hit. So then I call is even with 3 minus 2, which is going to be 1. So then I'm returning 1, so it should be false, right? So that should work.
It's not actually doing that though, is it? You're saying if it's 0 true, if it's 1 false. But if it's neither of those numbers, then just subtract 2.
Mhm.
Is it actually recursing? I don't think it's actually recursing. I think it's just taking the, I mean, it should be, but I think it's,
Okay.
I don't know if it's actually, it seems like it should. Because it's the else statement, but I'm wondering if it's just subtracting it and then just leaving it at that.
Yeah, so that's a good thought. So what is happening with this? So what does every function do when you call it?
Return
Returns
something.
value.
Yeah. So every function when you call it returns something, unless maybe it throws an exception. But so this is going to evaluate to something. This is going to be a real value. This is going to return. So if we call it with 3, it's going to return false. So we have a value here, but we're not doing anything with it. We're getting a value and it's just kind of floating around in the function. So we do in fact have to return this. Because if we don't return it, we kind of lose that. As soon as we break out of this, so that the reason the first 2 worked is because we were returning a value and that's it. So 2, 1, return it. If you don't return this, it's gonna call it and it's gonna keep recursing. It will actually recurse. It should actually get you the correct value, but you've broken the chain. If you don't return it, you break the chain, and so you can't capture that ultimate return value. So if we run it with this, and I didn't get any, errors, so all these tests pass. So just to reiterate that, when you have a recursive problem, you want to think about what is a trivial solution? What is an input that's going to be trivially, that's trivially going to answer your question? In this case, if we know that 0 is even, that's going to be it. If we know that 1 is odd, so these are our simplest possible input cases. So that is your base case. And the job of your recursive case is, number one, to reduce whatever your input is to one of your base cases. If you just have 1, then it's just 1. If you have 10, it's 10. But in this case, we have 2. So whatever you're doing, you can probably set up your base case without really knowing anything about without the problem. That's not always the case, but so let's say you can almost always figure out what the base case should be. And you should at least be able to know that you're going to have to recurse, and you're going to have to reduce whatever your input is so that it eventually gets to a base case. The specific logic of how you do that, you're going to have to figure out. But there's kind of a basic framework you can at least almost mechanically set up. Any questions about that? Okay, so we've got that. So I'd like to do another one. So this next one I want to do is I would like to write a function. So I'll write this out. In this function, let's say it accepts a list of integers, and it is going to return an integer, and that integer should be the maximum value of the list. And it's got to be recursive, obviously. So we start off with a list, and we want to return the maximum value of that list. So we can just set up the basic skeleton of the function. Someone like to walk me through that?
Def is largest.
Okay. So for it, there's kind of a convention where if you do something like is X or has X, then you're typically expecting a Boolean value. So in this case, we want to return an integer, not a Boolean.
Greatest value then.
Okay. This is going to be a list of ints, so we'll call it nums. And it's going to return an integer. So I can just kind of mark that as 0. So this is just the dummy thing, but I at least know something about this function. So I don't have to know anything else, but I know what it accepts and I know what it returns. All right, so now let's take a step away from programming and try to think about this problem. So we're going to not use programming, and we're just going to try and figure out what this problem is. So I have a list of integers. So how, I mean, there are obviously several ways of finding what the maximum is, but what should we do first when thinking about a possible solution for a recursive problem?
Think about the simplest solution.
Exactly. So what is the simplest possible what is the simplest possible input? So if I have a list of integers and I want to get the maximum of that list.
If
First, in the
if
list.
it equals one number length,
Yes. So if there's only one number in the list, then that's going to be the maximum, right? But like it sounds kind of stupid, right? It sounds like, well, of course, if I just have one thing, but that's kind of what you have to do. So if I have a list of one element, then I'm going to return that element. That's going to be the maximum. So we've figured out what our base case is. So if len nums equals 1, and I'm not going to worry about edge cases like passing in an empty list or anything like that. If the length of nums is 1, then return nums. So I can return that element. I'm going to go ahead and write some cases, some test cases. So assert greatest value 1. So that's going to be 1. And we'll just say, for the sake of doing this, 9, and then 1, 2, 3. It's going to be 3. And 3, 2, 1 is going to be 3. And 1, 6, 2, 8, 12, 0. It's going to be 12. This is probably good enough initially. We could definitely write more thorough tests, but this is going to cover, the base case. It's going to cover like a typical case. So thinking about different, edge cases or scenarios where you might be able to write a solution that isn't robust for all input. So if the maximum value is the last one, you could think of, it would be possible to write a solution where it works for something like this, where the maximum is the last, but doesn't work if it's not the last one. So here's one where it's just ascending, here's one where it's descending, and here's one where it's mixed. But there are other possible ones. I think this should kind of cover us. So if I now test this, so Python X, I get an assertion error and it fails here. 1, 2, 3 is 3. So the first 2 tests pass because those happen to hit our base case, and we don't have anything implemented. So unsurprisingly, those tests fail. Okay, so we know what our base case is. Now what about, let's kind of make that just a little more complicated. So now we have a list of 2 elements.
We need to compare them.
Okay. Yeah, so we need to compare them. So if we have 2 elements, we can compare this one with this one. Okay, so that's good. Let's hold that thought for a second, and let's go back to our function. So what is, let me do else. So what is our else statement what does it need to do, kind of. Let's not worry about the specific logic. What are some things we know about what this else statement needs to do?
Let's return the function, I guess, right? Because it's recursive.
Okay, good. So it's gonna need to do something like return greatest value, something that there could be additional logic here, but this is just and do we know anything else?
It needs to store the current value.
Okay, so I don't want to think about this specific problem. I just want to know in general, just based on what we have here, even if we don't know anything else about this problem, we don't know any of the logic, there's one other thing that we can be pretty sure we need to do.
I think we need to go through our list and eventually reduce it to a number of 1 to hit our base case.
Yes, so we need our base case is a list with 1 element in it. So we need part of the job of this, the recursive case, is to get to a list of 1 element. So we're gonna have to somehow return, we don't know exactly how to do that, but nums, I'll just do this for now. So we're gonna chop off the first element, the 0th index, and then return. So if I pass in this one, for example, someone walk me through in detail if I give it 1, 2, 3.
You'll give it 1, 2, 3, and then it won't meet the base case because it's got a length larger than 1. So when it gets called, we'll call it with the slice that starts at index 1. So we'll pass it a list of 2 and 3.
Okay.
And then that should call the function again, and then again not meet the base case. So then we'll take a slice of 2 and 3 from the first index, and that should just be 3, and then we should eventually meet the base case.
Yeah. So what is 1, 2, 3 going to return?
The last thing it will return is 3.
Yeah. So let me run our test again. And so this time it fails on 3, 2, 1. So even though our solution is not wrong, we're still passing these 3 tests. So this is why you want to make sure that you're right a number of different tests, because you might think at this point, if you only had a couple tests, if this happened to be your test input or something like that, some edge case and you didn't even know about it, you might think that you had a solution. Okay, so but this is kind of getting us in the direction of a solution. So we have the basic framework, we have our base case, which we know, and we have a recursive case, and we know that in a recursive case we have to recurse, and we have to break down the input until it reaches the base case. So if we have a list, that means we have to pass in a shorter list. We don't know exactly, is it, we're just arbitrarily chopping off 1. We don't know what the logic is here, but we know that it's going to be something like this. All right, so let's go back to the battery on my computer just doesn't want to charge when I'm using Zoom. All right. Okay, so let's think about this 8-1 case. So 1-8 would actually pass, right? So we just saw 1, 2, 3, it returns the last element, so that works. 8-1 will fail, but 1-8 will pass, right? So 1-8 will actually, it'll chop off the 1, and then 8 will be the last one, so the base case will hit and it'll return 8, and that will match. So we need to figure out this case. So we can compare the value. So what happens if
Are you gonna sort it?
Chad, can you just treat the list as if it's 2 elements long and say if element 0 is greater than element 1 or whatever, index 1,
Mhm.
then that is your greatest value, and then return to your function, your slice.
Okay, yeah, so I think that is, I think that's good. That's basically correct, I think. We should, you know, flesh that out a little bit though. So if we have an 8 and a 1, again, this is a, you know, the simplest kind of non-base case example. We want to compare the values, and if element 0 is greater than element 1, then what do we know about this 1?
Well, you
It's
have to
not
get rid of
maximum.
Yeah, exactly. So we know that this 1 can't possibly be the maximum. So we don't need it anymore. So we need to get rid of something. So let's get rid of the one that can't possibly be the answer. So what we're gonna do is we're gonna check. So if nums 0 is greater than nums 1, what we want to do is basically, it's a little tricky, but let's say we have a list right here. We want to chop off this element and then return the rest of the list minus this element. What if it's this? If it's here, sorry, if let's do 1. So if the second one is greater, then actually our solution works, right? We can chop off the first element. Because we know that this is not gonna, couldn't possibly be the maximum, so we don't need it. So we can just go for, we can slice it from index 1 until the end and return it that way. This case though, that doesn't work quite as cleanly. So there's a way in Python, you know, there are several ways of doing this, and Python has nice syntax, so you can actually just swap these values basically. You can do it in one line. So nums 0, comma, nums 1 equals nums 1, comma, nums 0. So we're basically just swapping these values. So if we have this case where the 0th element is larger, we can just swap them. So I'll just, sorry, my computer's moving very slow. This thing. Anyway, if I could move it, oh, no, it wants to move. So I swap them, right? I swap them and then I chop off the first index. So if the first one's bigger, I swap them, and then the 0th index is now going to be the lower number, so I can just chop it off. So let's try this. And that actually passes all of our test cases here. So we have a list. We want to get the maximum value. We think about the base case, which is usually kind of stupidly trivial, which is a list of only one element. The maximum is going to be just that element. So that's our base case. And we know that in a recursive case, we have to one, recurse, and two, break down our input until it matches the base case. So if we have a list, we need to somehow shorten the list. How do we shorten the list? That's kind of the part you have to figure out. So how do we shorten the list? What's the specific logic? Well, if the 0th element happens to be smaller, then you can just chop it off and pass in the rest. So that's easy. You don't really have to think too much about that. The other case where the first element, the index 1 element is smaller, then you have to swap them. I mean, there are a number of ways that you can. This is not the only way you can do. You can do this a few different ways, but that's basically it. Any questions about this? Okay, let's take a 10-minute break and we'll come back and we'll make this a little more complicated. All right. So we have this function that's going to get us the greatest value. Just real quick, what if we wanted to get the minimum value?
Could we just change our conditional to less than?
Yeah,
And then
I think all we have to do is that, and then we get the minimum value. Okay, so we have a function that gets the maximum value. Now what I want to do, I'll comment these out for now. I'll just make a new copy of this. All right, so we have our greatest value function. Now what I want to do is I want to get a sorted list. So write a function that accepts a list of integers and returns a sorted list. So we can use this, and what we're gonna have to do is write another function that uses this function. So I'm gonna set this up. This is gonna be recursive, of course. So def sorted list. This is gonna take a list of integers, as we said, and it is going to return a list. So this is a little tricky. Let's go, before we start coding, let's kind of think about this problem. So if we look at how our maximum works, we start with this. I'll make a, see if I can copy this. This. All right, so we have this list, and the way we're doing it is we check these first two, and if this one is bigger, we swap it, and then we just get rid of it, and we pass in this new list, and then we compare these two. If this one's bigger, we swap it, and then we chop this off and pass this in. And then we do the same thing. This is bigger, we swap it, and we chop this off, and then if our lists have one element, then we return that element. So if you kind of notice how this behaves, it's like the 8 kind of jumps up to the top of the line eventually. So there's something called bubble sort. Did you guys implement bubble sort earlier?
We did do it in FOP, but I honestly don't remember it. I know that we covered it though.
Yeah, that's fine. So what we're doing is we're now going to implement bubble sort recursively. And part of doing the bubble sort is getting the bubble part. So we have the bubbling up part. So if we have a list, we can always get the maximum value by kind of incrementally, step by step, moving it up to the top of the cube or something. So now if we want to sort this list, how could we do that using what we already have?
You would have to kind of traverse the list instead of pop the numbers off.
Okay. So let's say that what we actually want to return here is a new list. So we're not going to modify the list in place. We're going to actually return a brand new list. So if we kind of start with this, we can get the max of this list, right? We can bubble this up. And then we can create our new list over here. So we need to not only do this bubbling, but we need to create a new list. So we can start with this list, use our max, bubble this 8 up, right? And then this 8 we know is going to be the maximum value of our new list, right? So we can set that aside over here. So we're going to create a new list over here. And then with the rest of these, what do we do?
Same thing.
Yeah.
Same thing. And
So we're going to compare this. In this case, it's going to be a 5. So the 1's going to get chopped off. And this 5 is going to bubble up. Ultimately, the 5 is going to be the max. And we can set that over here. And then we can do the same thing again. So the max of this list is going to be a 3. So we can put that over here. And then the max of this list is going to be a 1. And so we can put that over here. So we're going to basically execute the max for every single element in our original list. And then we're going to build one at a time a new list. So this is, obviously a little more complicated. So the base case for this is maybe a little trickier. So I'm going to copy this and then
Oh, baby. Okay.
so if I start with this list, I want to end up with this list. And this list, I'm going to have to build up incrementally, one at a time. So how do I know if I'm done building up this list?
If the
you
length is
Okay.
equal to the original.
Yeah. So if this list I'm building is as long as my original list, then I know that I've kind of gone through and used everything up. So that is going to be our base case. So we're somehow going to need another list. We'll worry about that in a second. So if len nums equals len, we'll just call it new list, then what are we going to return here?
New list.
Yeah. Now, where is this new list going to come from?
You'd have to declare it, wouldn't you?
Yeah, we're gonna have
Do
to,
empty array or empty list.
okay. So let's say we do something like this, so new list equals an empty list. So we'll try it like that for now, else we're gonna have to do something. So what do we know, without worrying about the logic, what are some things we know about the recursive case? What is it gonna have to do?
Reduce the amount of element in the list. Or in nums, basically, like decrement.
Okay. So what is how do we satisfy our base case?
We have to build a new list until it equals the same length as the original.
Yeah. So in this case, we are kind of breaking this down, like reducing it, making it smaller. In this case, we actually need to make something bigger. So we're somehow going to have to append maybe something to this list. So I'll just do so just as a placeholder for now, new list dot append something for now. So I'll somehow have to make this list bigger and then do something else. So we're not worrying about the logic right now. We're just getting the basic framework. So I'm getting my solution closer to the base case. What else do I have to do in the recursive part?
You have to recurse.
Yes. So return sorted list with something. I don't know what. So this is not correct, obviously, at least not exactly, but this is kind of tells us what we need to do. We somehow need to grow this new list and we need to call sorted list.
Are you allowed to use list comprehension and recursing?
I mean, list comprehensions are not recursion, but I mean, you could definitely use a list comprehension within this. I don't think we will need to use list comprehension in this case, but that's something that we could definitely do. So we have this problem where we want to return a new list. So one question would be, if I call this function recursively, what happens to new list? So I've appended something to this new list, and then I return sorted list with something, nums in here. So I'm building up my new list. I'll just do this. What happens when I call it this time? What happens to new list?
It's just gonna be like set back to an empty list again.
Yeah. So we have a problem where we're like we call the function, we get closer to our base case, but then when we recurse, that just gets obliterated. So we need a way to preserve this value every time we call this function.
When you no, when you call the function first, like the very first time,
Mhm.
could you just declare the new list as a variable in the function and just have it set to empty there?
Yeah.
And then
So what we can do to get around this problem is for this particular problem, we need this information to be preserved. We need to modify this and then preserve it for each function call. So one way you can do that is use a default parameter. So new list. And we could do something like this. There's actually a kind of a quirk about this, so you shouldn't actually do this with arrays or dictionaries, but we can do this. And then we can do new list equals new list if new list, else an empty list. So does anyone have any idea what this line will do?
Is that like a ternary operator?
Yep. Yeah, it's basically a ternary operator. So the first time I call this function, new list is going to be none. And then if new list is none, the new list, we're going to set it to an empty list. And then we'll go through, and when we call it again, we're going to have to actually pass this new list in. And then, so we've modified the new list to bring it closer to our base case. And then we pass it in, and the next time, new list is not going to be none because we'll have passed it in as a parameter. So new list will just be whatever it is. So we have to do this check the first time we call the function, and then after that, it's just going to be whatever this value is. So if I execute this, I'm going to write some test cases. So assert sorted list. 1, 2, 3 equals 1, 2, 3. Is there a question? And we'll do 3, Q, 1. And 1, 2, 3, 2, 5, 1. Actually, I don't think I want to write all those numbers. 1, 2, 5. We'll just leave it like this for now.
Wouldn't the line 66 one be equal to 1, 2, 3?
Oh yeah, sorry, you're right. 1, 2, 3. Thank you. Okay, so I'm gonna go ahead and run this, and we get an assertion error. So fails on this first one. Fails because we're just appending 0. So we're returning 0, 0, 0. But we didn't get an infinite loop, right? So we are actually, if we didn't append this at all, it would just recurse forever without ever reaching the base case. Then you get a maximum recursion depth error. So we can try that as well. So in this case, we're not actually breaking down the problem. It never will reach the base case. Now we're actually going to reach the base case. It's just with some arbitrary nonsense that we put. So, so what we need to do is build up this new list with the maximum, right?
Would you in the dot append, would you pass in the recursive function above it?
Yeah, let's try that. Greatest value, and that will be nums. And if we call this so what's going on here?
I think you have a list of just 3, 3, 3.
Okay. So if we walk through this the first time, so we're going to get an empty array here, and then we're going to append what is, so if we start with 1, 2, 3 as input, so what is the greatest value of 1, 2, 3? It's 3. So we're going to append 3 to the new list, and then we're going to call this sorted list again with 1, 2, 3, and 3. It's going to get called again. And what's the greatest value of 1, 2, 3? 3.
3.
So what are we missing here?
We're not changing the size of our list.
Yeah, which list do we need to change?
Numbers.
Yeah. Okay. So what we have to do is we get the greatest value from nums, right? So in the case of 1, 2, 3, that's 3. And once we have the maximum value, we don't want that anymore, right? We want to remove that from this list. So we just want to call it the next time with 1, 2. So we're going to need to do something else. So what I'm going to do, we could also write yet another recursive function, but I'll be nice and say we don't have to do that. So maximum equals something like this. And then we can actually use, we can basically pop off. So we can search in the nums and then remove it. So we can do, oops, nums dot remove maximum. You can definitely implement this remove recursively, but we'll just not do that for now. So we're going to get the maximum of this nums list. And then we're going to remove maximum from this input list so that, for example, we only have 1, 2 now. And we're going to append to our new list. Sorry, not 3, but maximum. And then we're going to call this again. So now when we call this a second time, if we start with 1, 2, 3, now nums is going to be 1, 2, and new list is going to be 3. If we call it again, we're going to get the maximum of 1, 2, which is going to be 2. We're going to remove that, and we're going to append 2 to our maximum. So we're going to have new list now with 2 and 3, and nums with just 1. And we're gonna go through that again, and this time nums will be 1. So we have a slight issue now with our base case, right? So let me just call this.
So eventually, because you're comparing one thing with another, now you run into a point where there's nothing to compare with, and that's why the error is happening.
Yeah. So there are a few different ways we could implement this. So the way we've implemented this now basically doesn't agree with our base case anymore. So we could change this, or we could change this. So I'm going to vote for now that we just change our base case. So what is our new base case going to be?
If len nums equals 0.
Yeah. Okay, so let's try this. Okay, so we got an assertion error. So if we're not sure does anyone happen to know what's happening?
I'm not sure, but the nums.remove, that was, so when we have maximum equals greatest value, and then you go nums.remove maximum,
Mhm.
and then you're appending maximum, aren't you appending nothing? Or am I reading that wrong?
Yeah, so that's a great question. So we're basically taking taking an integer out of the array and storing it in this variable right here. Then we're modifying the array, but because this is a primitive type, we're basically making a copy of it. So this is now separate from the nums list. So that's a good thought, but we're not actually losing this value.
Okay.
Well, so a couple options when you're in a case like this where, it's not giving you the output you expect. You could try to walk through it individually, which we've done a few times. You can also use the debugger to try and figure this out. So I'm going to use. Yep.
Never mind, never mind.
All right, so we'll just go ahead and walk through this. All right, so I know, so I'm just going to keep track of a couple variables specifically. So I want to watch new list. And I also want to watch nums. All right, so I'm gonna start calling this. So we're gonna start here. So I can see that new list is now gonna be, the first time I call it, it's gonna be this empty array, and here's our nums input. So I'm gonna step through here. What's the maximum? We're gonna call this. We'll walk through this. It's a little tedious, but my computer is very slow right now. All right, so what is the maximum of 1, 2, 3? It's 3. So that's what we'd expect. So keep going. So nums, remove maximum. Now what is nums? 1, 2. So we removed the 3. And let's also, I'm going to watch maximum. So maximum, you can see all these values up here, by the way, but this is just like if you want a specific subset, it's easier to track. So maximum is 3, which is correct. And our new list is 1, 2, which is also correct. So now let's call this. So we've now appended 3. That's also correct, right? Or seems correct. So we're going to recurse now. We're going to keep going. So new list, note that new list is not starting at an empty list again. So we're preserving the list that we've built so far.
So the order we're building it is not correct, basically.
Yeah. So we'll keep going just so you can see that explicitly. All right. So we're gonna get the maximum of 1, 2, which we're expecting it to be 2, right? Okay. So now the maximum, it should be 2. Maximum is 2. Nums is 1, 2. New list is 3. So we're gonna remove the maximum. So now nums is 1. And we're going to append 2 to this new list. So you see our new list now is 3, 2. So we are sorting this. We're just sorting it in reverse order. So what should we change in order to?
We could use insert instead of append.
Okay. So insert. Do you also insert the index and the object? Okay, so at 0. Does Python also have like a push or something like that? Where you can, or shift, whatever that is.
I don't
I think
on this.
I
Maybe.
thought it was extend, but I'll check.
okay. Well, I think this should work anyway, but I'm sure there's several ways to do that. All right, so now let's go ahead and run it, and this time our test cases pass. So we could write more test cases to be sure, but I think this should work. So now we have kind of two recursive functions. This is now basically a helper function that's recursive, and we're using that to generate a new list. So I'm going to call this bubble sort, and let me change this. Okay. So we just implemented bubble sort recursively. So just to review this again, we start with some unsorted list that we want to sort, and we need to make sure we're building that up. So we're just going to include this as a default parameter. The first time we call it, new list is going to be empty because we're going to build that up. And our base case in this particular implementation is going to be if nums is 0, because we're going to break that down. We're going to chop up the original nums list and use that to build up our new list. So once this is empty, we know that new list is full. And then we're going to use our helper function to get the maximum value of this list, because that's going to be at the end. We're going to remove it so that we don't just get the same a list of whatever the maximum is. And we're going to insert this into the 0th spot, and then return bubble sort, blah, blah, blah. Any questions about that?
No, but I definitely feel like I need a lot more practice on this.
Yeah, that's totally understandable.
I guess if we knew we were going to sort in this way, would it have been better to just copy our greatest function and then change it to minimum, and then that way just use append?
Yeah, you could definitely do that as well. So yeah, that's a good. So what's the? Well, we're going to talk about data structures later. What's the? Does anyone happen to know about like runtime complexity?
Yeah, a little bit, but I'm not super good with it.
Okay.
But I know if you insert at the beginning, you're like shifting all those elements, versus like if you're appending to the end, like the only thing that needs to change is that last value.
Yeah.
So it's like slightly better.
Yeah, exactly. So you don't need to worry about that right now, but there is there's a performance benefit to using append rather than insert here. We'll talk more about that later. Okay. Cool. I'm gonna stop this.